Hello, everyone. Welcome back. Today, I'm going to be talking about solving rational inequalities. Okay, so today, let's start with example one. It says, use the graph to find when x minus 7 over x plus 2 is greater than 3. Okay, so where is it greater than 3? Well, here's where it's equal to 3, right? Here's this 3 line, right? Where is it greater than this line of x equals to 3, right? So don't get this mixed up. This line here is not an asymptote line. This is a line showing where x equals 3 is, so that we can easily see where, where this graph is greater than 3. So everywhere above this line, so all of this space, it's greater than 3. And what's that with respect to x? Well, that starts around here. Okay, around the -6 mark, and then ends. Well, let's see. This looks like there's an asymptote at x equals to -2. So I would say it ends at -2. So therefore, our answer is going to be -6, comma, -2, like that, right? From -6 up to -2. Okay, so the next question asks, use the graph to find when x is less than 3 over x minus 2. So in other words, where does this graph, looks like it has an asymptote right here, when is the line less than the graph? Well, the line is clearly less than the graph over here, right? The line is also less than the graph in this little space right there. I think the highlighter is too big to get it, but to do it right. But yeah, exactly, in that space there. I'm going to try to do that a little bit better, actually. Let's pull it in with just the purple color, just that little part right there, okay? That part right there. Excellent. Okay, so where is that? Where is that? That is from -infinity all the way up to, looks like -1, and then again from 2 up to 3, and from 2 to 3. Good. All right, let's move on to example 3. So starting with example 3, we've now got to do it algebraically. So how do we do this algebraically? So first thing I'm going to do to solve this is we're going to find what we call restrictions. Okay, so what is a restriction? It's something that our answer cannot be because it results in something undefined. So in this case, we have a restriction at x is equal to 4, right? Because if x is equal to 4, then our denominator is 0, and we can't have that, right? We can't have that. Okay, so now let's solve this. So first thing I'm going to do is I'm going to get everything onto one side. So I'm going to put the 2 on the other side, and we're going to get x squared minus 4x plus 4 over x minus 4 minus 2 is less than 0. Then I'm going to make the denominators the same. So I'm going to grab x squared minus 4x plus 4 over x minus 4 minus 2x minus 4 over x minus 4, like that, is less than 0. And then we're going to subtract. So we've got x squared minus 4x plus 4 minus 2x plus 8 over x minus 4 is less than 0. And then we have x squared minus 6x plus 12 over x minus 4 is less than 0. And then we want to figure out, where is this less than 0, right? Because we can put this up here, and now we just need to figure that out. Okay, so x squared minus 6x plus 12, where is this less than 0? Well, in order for this to ever be less than 0, right, because this is a parabola that opens up, keep in mind, right, we need to make sure that there are zeros, right, that there are some solutions, so that way it does go downwards. So let's do that. Let's use our quadratic formula. So x is equal to 6 plus or minus b squared, so 6 squared, or I guess -6 squared technically, minus 4ac all over 2a, which is 6 plus or minus 36 minus 48 over 2, which is 6 plus or minus negative root 12 over 2. So there are no solutions. So it turns out this parabola has no solutions. Okay, so what does that mean to us then? Well, if the parabola has no solutions, then that means that from negative infinity up to negative 4, or sorry, up to 4, then it's negative. Also at x equals 4, it's undefined. And then at x is greater than 4, or from 4 to infinity, overall we have something positive, right? We have no way to make the top 0, right? And so we just need to consider the asymptote that we have, the restriction we have here, and figure out which of those places it's going to be negative versus positive. And what do we want in this case? We want places where it's negative, places where it's less than 0. Okay? So therefore, it's only this one that we actually care about. So the answer, therefore, is just from negative infinity up to 4. Awesome. Okay. Example 4, find all the values of x that make this inequality true. Okay, so first things first, it looks like we can actually factor this. Looks like we might be able to factor this. So I'm going to do that actually. We could factor this and say this is the same as x minus 2 over x plus 4 over x minus 2 is less than, or sorry, is greater than 0. Okay. So therefore, what are our restrictions? Our restrictions are x equals to 2, right? So we have a restriction at x equals to 2. And we need to figure out which intervals it's positive versus negative. So we have the points on the top as well. We have to consider of where the top is 0 for this one. So we need to figure out all of the intervals. So the first interval is negative infinity up to negative 4, right? Because negative 4 is a 0 with respect to the top of our function. Then we also have where x is equal to negative 4. Then we have from negative 4 up to 2. Then we have at x equals 2. And then we have from 2 to infinity. Okay. So then we have, over here, we have something negative, right? Because if we plug in like negative 5 here, we're going to get negative times negative over negative, which is negative. If we plug in x is minus 4, we're going to get 0. If we plug in something between negative 4 and 2, like we plug in 0, we're going to get something positive here. And if we plug in x is 2, we're going to get nothing. We're going to get something undefined because that's a restriction. And then if it's something greater than 2, where it's going to be positive again. It's going to be positive once again if it's greater than 2. So there we go. So we want to know, where is this whole thing greater than 0, meaning where is it positive? Not where is it equal to 0 or undefined or negative, but where is it positive? So that's in these two places. So these two places are going to be our answers here and over here. So therefore, awesome. Okay. Now let's move on to example 5. Example 5 says, find all the values of x that make this inequality true. Okay, so to do this, first I'm going to get everything onto one side. So we want for 2x plus 1 over 2x plus 3, or sorry, minus 3, minus x plus 1 over x minus 5 to be greater than 0. Okay. So first we've got to make the denominators the same. So let's do that. So we have 2x plus 1, 2x minus 3, x minus 5, x minus 5, minus x plus 1, x minus 5, 2x minus 3, 2x minus 3 is greater than 0. So what will that be? That's going to be 2x squared minus 10x plus 1x minus 5 minus, let's see, 2x squared plus 2x minus 3x minus 3 all over 2x minus 3, x minus 5. Okay. And then we're going to get 2x squared minus 9x minus 5 minus 2x squared. And then let's see, that would be minus x. So plus x plus 3 greater than 0. Okay. And then we're going to have negative 8x minus 2 is greater than 0 over 2x minus 3, x minus 5. Okay, awesome. So what are our critical numbers then? Well, they're going to be negative x minus 2 is 0, which means negative 8x is equal to 2, which means x is equal to negative a fourth. Then also x is equal to 5, x is equal to 3 over 2. Awesome. Okay. And then we have negative infinity up to negative a fourth. X is 1/4. Okay. And then we have negative 1/4 to 3 over 2. And then x equals 3 over 2 up to 5. Actually, let's be consistent here. I'm switching from to the different notations. So let's keep them there. 3 over 2 up to 5. And then we have x is 5. And then we have 5 to infinity as our last one. Oh, we don't have enough space. Shoot. Okay. 5, x equals 5, 5 to infinity. Okay, there we go. All right, so between negative infinity and negative a fourth, what would it be? Would it be negative or positive in our original? So let's do that. So if we put negative 1 into here, what will we get? We're going to get something positive. At negative a fourth, we're going to get 0. From negative 4 to 3 over 2, well, I'm going to choose a number in that interval, like 0, we're going to put it in. If I put in 0 here, we get negative 2 over something positive, because negative times negative. So we get negative over positive, which is negative over all. For negative 3, or for 3 over 2, sorry, it would be undefined, as it would be actually for here as well, right? Because those things are, our denominators are 0 there. Then what about for 3 over 2 to 5? So what if I plug 2 in here? We're going to get something positive. And then what if it's over 5? So something like 6, we would get something negative. Good. And what did the question want? The question wanted where is this function greater than 0, right? So where is this function positive, in other words? So therefore, we want this one because this is positive, and we want this one because this is also positive. So these are the two we want. So therefore, our solution is negative infinity up to negative a fourth, and 3 over 2 up to 5. And there we go. Awesome. All right, well, that is it for today. Good work, everyone, and we'll see everyone next day. Bye, everyone.